everybody, to the Pink Ribbon Roller Coaster. We're so glad you're joining us today. Again, we have an amazing guest. He's a dear friend of mine. His name is David Raubach. He is the Chief Development Officer of the Oklahoma Proton Center, as well as the premier Breast Health Institute. So I'm so glad you joined us today. Welcome.
Thanks, Sarah. I appreciate the opportunity to come on your podcast. You came on my podcast, so I'm glad that we could reciprocate and I can come on your podcast.
Yeah, that's what friends do.
Yeah.
We will definitely get to that. But first, I wanted to talk about, so primarily we want to discuss protons, proton radiation. I know that this word comes up a lot, and some women don't even know that it's a possibility for them. So first, just explain to us, what is proton radiation?
Sure. Yeah. So proton radiation, when we think about protons, I think for the listeners out there, think back to high school chemistry class and the construct of an atom. So an atom has a proton and a neutron and an electron. And then if there's more protons and more neutrons and more electrons, and that changes the type of atom. And so what we are literally doing is we're taking proton particles from hydrogen gas and we're accelerating those protons to really high speeds. And then we're delivering those protons down a beam line into a treatment room. And from there, those protons go into a patient's body. And the really cool thing about protons is that because they have a mass and they have a charge, we can use those physical properties to our benefit or our advantage and tell that proton where we want it to stop inside the body. So literally, we say we want that proton to go 10 centimeters into the body or 20 centimeters or 30 centimeters. That's where the malignant cells are. And we want to deliver hundreds of millions of protons into those malignant cells. We can deliver those protons at just the right speed so that they stop inside the cancer cells. And that contrasts with the other type of radiation that often gets used for cancer treatment, X-ray radiation. So X-rays, if you think about X-rays, when they go into the body, they can be targeted at cancer cells, but they don't stop when they go inside the body. And so oftentimes you'll get extra radiation exposure to healthy cells that are beyond the depth of the tumor. When you think about breast cancer and you think about where we're delivering radiation, you have all of these really important structures in the chest: the heart, the lungs, the spinal column, the esophagus. We want to avoid hitting all of those structures or those critical organs as much as possible.
Mm-hmm.
And so with protons, a lot of times we can deliver less radiation to all of those healthy organs than we can with X-rays because we can stop protons inside the tumor. And so with protons, so just to rehash, the simple way to think about it is proton radiation can be stopped inside the tumor. X-ray radiation cannot be stopped inside the tumor. We're still delivering the same amount of radiation to the cancer cells, but you're going to get less radiation to healthy tissue most of the time with protons. And so then another question that we get asked a lot is, well, what can be treated with protons? Any type of solid tumor that we can see on medical imaging, so whether that's an MRI or a CAT scan or a PET scan, if we can see that tumor on medical imaging and it's a solid tumor, meaning it's not, for example, like a blood-borne tumor that's traveling throughout the body, it's stationary, we can target a beam of protons at that tumor and use protons to kill all of those cancer cells. So that could be brain cancer, head and neck cancers, ocular cancers,
Wow.
all the way down into the thoracic area, breast, lung, the abdominal area, liver, kidney, colorectal cancers, prostate cancer, soft tissue sarcomas, etc.
Wow. That's amazing. And how long have protons been available for breast cancer patients?
So what's interesting about that question is that the first patient was treated with proton therapy in 1954 out at a research laboratory in California, Berkeley. At the time, it was just called the Radiation Laboratory. And there was the first patient that was treated with protons was actually a breast cancer patient.
Really?
Now, from 1954 until 1990, there was limited use of protons because you didn't have advanced diagnostic imaging. So you didn't have CAT scan or MRI. The CAT scan comes out in the 70s. MRI becomes more widely available in the 80s. So then we really have a good understanding of what's going on inside the body, which we need that information to be able to tell protons where to stop inside the body. So
Mhm.
once you have that, then that ushers in what we would consider the modern era of proton therapy. And the first modern dedicated proton center opened at Loma Linda University in 1990. So then from there, Mass General Hospital up in Boston opens a proton center in the late 90s. MD Anderson opens in the early 2000s. So these are big names in
Mhm.
cancer care. And
Mhm.
the Oklahoma Proton Center opened in 2009. And it really was, I would say, about that time, kind of the mid 2000s, 2010, 2015, 2015, where we were really developing the protocols needed to treat all different types of breast cancer with protons.
Mhm.
And so we have been at the Oklahoma Proton Center, been treating over 100 breast cancer patients a year for probably the last 10 years or so.
That's awesome. So I know that, because it is a fairly new modality, there's not very many centers across the nation that so this is very unique that we even have the possibility to do this here in Oklahoma. Can you talk a little bit about that too?
It is. So when the Oklahoma Proton Center opened in 2009, it was just the sixth proton center in the country. And so as a result, we've actually treated patients from all 50 states and 16 different countries. So we had
Mm.
patients traveling from literally all over the world to Oklahoma City for treatment.
Mhm.
Today, there's about 45 proton centers in the United States. But that contrasts with probably over 2,500 or maybe even 3,000 X-ray radiation facilities. So when you think about the
Wow.
number, there's almost, there's 8 or 10 X-ray facilities for every one proton center, right?
Yeah.
Well, no, I didn't even do that math right. It would be 100 X-ray facilities for every one proton center. And so, and the reason for that is really the cost of the facility itself.
Mhm.
So if you think about our center here in Oklahoma City, we have to have a particle accelerator. It's hard to build a particle accelerator. There's a lot of costs and a lot of infrastructure. You need a lot of space. And so it's just, you're just not going to see that many, whether it's hospitals or private doctor groups, be able to afford to put in protons, which is why, even though there's a lot of clinical benefit, right now there's still only 45 proton centers in the US. But all of the top cancer centers, Mayo Clinic, MD Anderson, Johns Hopkins, Harvard, Memorial Sloan Kettering, all of these that you would see as like these are the top research cancer centers in the country, all have multi-room proton centers.
So you had mentioned the, particle accelerator machine. Is that the cyclotron? Is
That's the cyclotron, yeah.
So talk to me about that because whenever you give the tours at the center, I love you talking about the history of the machine and all that. So talk to us about that.
Yeah, so the cyclotron is an amazing device. So our cyclotron weighs 200 tons. So to put that in perspective, that's about 100 full size or mid-sized cars worth of weight. So there's only a few companies in the world that can actually install these really, really heavy devices. It can accelerate a proton to 2/3 the speed of light, which is about 120,000 miles per second. To put that in comparison, the circumference of the Earth is 25,000 miles. So that means at 120,000 miles per second, that proton can be accelerated to a speed where it could almost get around the Earth 5 times, so 4.75-ish times in 1 second. So the snap of a finger. So
Wow.
it's a really powerful device, but it weighs a lot. The cyclotron was invented by a guy named Ernest Lawrence back in 1929. He built the world's first cyclotron at the radiation laboratory at Cal Berkeley. And then there's a connection actually back to the Manhattan Project. So most people are familiar with that. That's the project that the government initiated and funded to build the world's first atomic bomb during World War II. Well, a lot of the leading scientists that understood nuclear technology, nuclear physics, nuclear engineering worked at Cal Berkeley Laboratory, at the radiation laboratory. And one of the people working at that laboratory was Robert Oppenheimer. So probably a lot of people have seen the movie Oppenheimer. Well, Robert Oppenheimer was working at Cal Berkeley Radiation Laboratory. Ernest Lawrence was working there. And then there was another guy named Robert Wilson, who was a PhD student studying under Ernest Lawrence. So they all joined the Manhattan Project. And as Robert Wilson recalled this story later in life in an interview, he said, I was reluctant to participate in the Manhattan Project initially because I was a pacifist. I'd been raised as a Quaker. I didn't want to participate in this war effort. But ultimately, for a variety of reasons, he ends up joining the project, one of which was that his wife was actually Jewish. So he had this personal reason as he started to hear about these stories coming out of Nazi Germany. He said, well, I have an obligation to do my part to stop what's happening in Europe. But what he said is that when the first bomb was detonated, the Trinity test out in the desert in New Mexico, he said, I was overwhelmed with the devastation and destruction that I had been a part of creating. And then once those bombs were dropped on Hiroshima and Nagasaki, he said, I committed my life to looking for altruistic uses or beneficial uses of the technology that we had refined and developed on the Manhattan Project. And a big part of what was worked on the Manhattan Project was this ability to accelerate subatomic particles and control them and know how many were coming out of the particle accelerator. And so in 1946, Dr. Robert Wilson wrote a paper called The Radiological Use of Fast Protons, which basically the gist of the paper was protons can be used to treat cancer, and here's how it would work, and here's why it would work. And what we do today is in large part based on the physics and the engineering and the biology that Dr. Robert Wilson, who we call the father of proton therapy, it's what he wrote up in this paper in 1946. And again, as we talked about earlier, the first patient was then treated in 1954 back at the radiation laboratory at Cal Berkeley, where all of these brilliant scientists had been working. And that patient was, the doctor who treated that patient was John Lawrence, who was the brother of Ernest Lawrence. So Ernest Lawrence invented the cyclotron, and then his brother, I guess about 25 years later, uses that cyclotron to treat the first cancer patient with proton therapy. So it's a really cool story. I'm a history major.
Yeah, that's
I geeked out on that stuff.
Very.
Yeah.
I love that. Okay, so now that we've talked about all that and we know the difference between X-ray versus proton, and you've talked to us about how it's administered. So if I'm a newly diagnosed patient, how do I figure out if that's a possibility for me as a patient? What should I do?
Yeah, that's a great question. So I think the first thing and a lot of patients probably know this, but there's three kind of big buckets that we use to treat cancer: chemotherapy, surgery, and radiation therapy. And within chemotherapy, medical oncologists oversee that, and I'll put immunotherapy in maybe a separate bucket, but administered by medical oncologists. Surgical oncologists do the surgery. Radiation oncologists handle radiation. About 50% of cancer patients in the United States are going to get radiation as part of their treatment. Mm-hmm. If at any point you as a patient have been recommended radiation, told you need to consider radiation, that's a trigger to say, okay, well, proton therapy could be the type of radiation that's used, right? Mm-hmm. So then for us, we try to make the process really easy because we know lots of patients have questions. There's a lot of information on our website, okcproton.com. So we try to put a lot of information out there about how protons work, who it's applicable for. There's lots of insurance questions, which we can get to. Mm-hmm. But then if you still have questions, you can just call the facility. You don't need a physician referral to see a radiation oncologist. You can actually just call our facility, call the front desk. We have somebody answering the phone, and they can get you scheduled to talk to a doctor as well. And I would say, Sarah, you and I have talked about this. If you're a cancer patient, you owe it to yourself to be your own best advocate. There's not anybody else that's going to advocate more for you than you. And so part of what that often can mean is considering all of your possible treatment options. We like to think of healthcare and we like to think of cancer treatment as a science, like, oh, well, there's just a playbook and everybody goes to the same playbook. I would say it's as much of an art as a science, mm-hmm. because every person is unique. there's literally cancer is this big umbrella, but there's literally thousands of different types of cancer when you really dig into the details. And so sometimes it's important to talk to multiple different doctors, get a few different recommendations or opinions about how to approach treatment. And then you as the patient are educated to make the best decision for you. And that may be proton therapy, it may be something else. And again, those decisions are applicable for chemotherapy, for immunotherapy, for surgery as well.
I love that. And I love that you said that because when I'm talking to girls, as soon as I hear them talk about the possibility of radiation in their protocol, I introduce the idea of protons to them because honestly, that is not being talked about a lot. And we really have to advocate for ourselves and look for the possibilities that are available to us. And I love the Proton Center too because, as you and I talk a lot, it really it's holistic, mind, body, spirit, and I really love how the Proton Center cares for their patients too. You really feel a sense of family and belonging, and they're truly caring. Not that others don't, but I really do love that, how it's unique, and you're really intentional about that too. And because it's not necessarily if you're in a specific institution and you're going to go to this doctor, this doctor, this doctor, and they all are kind of on a team. Like the Proton Center is a little bit different, ladies, because you are going to have to seek that out for yourself. That's probably not going to be something that's naturally brought up. So that's why this is really important for us to discuss because we need to know that it's a possibility for us. So let's say you answer my question, you don't need a referral. So I'm interested in learning about this. So like David said, you can just call and you can schedule an appointment, go in for a consultation. So let's just say, okay, I've decided I am going to go with protons. What does it look like when I come in for my appointment?
Yeah, that's a good question. And one thing I will mention, because you talked about health system and the Proton Center, we are an independent not-for-profit, which means that we're not part of any hospital system, but we do work collaboratively with and treat patients from all of the different hospital systems. But our focus, and even though we're called the Oklahoma Proton Center, we actually do traditional radiation as well. So when you come in for a consult, our radiation oncologists are looking at all of the options, all of the different types of radiation. We have tomotherapy, a tomotherapy machine, which does volumetric arc therapy treatment. Some breast cancer patients are going to benefit from that or get that type of radiation delivery. We do intensity modulated radiation therapy or IMRT, and then we do proton therapy. And so our doctor is going to consult you for all of those potential options. So in terms of just the process, you'll come in, come to the front desk, go to the back and meet the nurse, and then ultimately you'll get a chance to talk to the doctor. We have 3 full-time radiation oncologists at the facility, and then we have some other radiation oncologists that practice part-time. I promise they will spend as much time with you as you need. We're here to do the absolute best possible job delivering radiation if radiation needs to be a part of the treatment. And I think the other thing we really try to focus on, Sarah, is we believe that we have this really beneficial technology with proton therapy, but we also want patients to have the best possible patient experience that they could hope to get going through this process. And we talk about this, and this is one of the comments that we get with patients as they finish treatment a lot of times is, well, everybody's smiling. And it seems counterintuitive for everybody to be smiling at a cancer center. But we actually think that because it's a cancer center, you should smile because we know that patients do better going through treatment if they have less stress. And the last thing that we need to do is take this have this very somber approach to the experience here at the Proton Center when there's enough stress that comes with a cancer diagnosis. There's physical stress, there's emotional stress, there can be financial stress, there can be psychological stress, spiritual stress, whatever it is, that all exists. We know that. And so what we need to do is try to relieve some of that stress by creating a friendly, accommodating, welcoming place for patients to walk into. And we're going to actually try to smile a little bit and laugh a little bit during the process. But there's also going to be days where we just need to cry through the process. Whatever those emotions are, we want this to be an emotional safe space and safe place for that to just get released. And that's sometimes hard to do when you walk into a healthcare facility. You put your you put your shell on, and it's like, hey, I got to be strong. I promise you, our radiation therapists are used to just crying with patients
Mhm.
when they come into the room. That's okay. We want that to happen.
Mhm.
You need to feel comfortable just, again, expressing whatever emotion you're feeling that day,
Mhm.
going through this really overwhelming, difficult process.
Mhm. I feel like you really do, you do an excellent job of that. I mean, every time I'm up there, you're celebrating, people are ringing the bell, there's families together, and you just do things a little bit different, which I appreciate that. So after they've had their consult, they've decided they are gonna go with the Proton Center. You did mention this a little bit about the insurance thing, because
Mhm.
I know sometimes, um when we are talking about when we're good at the first step, whether it's, surgical oncologist or medical oncologist, like, you kind of as a patient, you're just kinda going through the motions, you're going to where the people are telling you to go, and oftentimes that is dictated by our insurance. So, is that can that be a hiccup or a roadblock sometimes for women?
Yeah, so that's a great question. So specifically with proton therapy, Medicare offers broad coverage. So if you're Medicare age and you have Medicare, or I would say 95% of Medicare Advantage plans, you're not going to typically run into any issues with coverage, and there's going to be some consistency about what the out of pocket is going to look like. And so Medicare is covered. Then with commercial payers, they're going to take it. That's going to be on a case by case basis. Overall, we get about 80% of commercial cases approved with an insurance company or an insurance plan when the doctor recommends proton therapy. So that's four out of five times it's going to get approved. And I would say for left-sided breast cancer, where you have the heart
Mhm,
potentially in the radiation field, that percentage is even higher. It's rare that you're going to have an insurance company that's going to say keeping radiation. There's no benefit to keeping radiation off the heart. But we have a financial counseling team that walks alongside with the patient, helps them understand exactly what their responsibility is going to be. We are also a not for profit, and so as a not for profit, we have some charity options for patients if they're not. If for some reason, even if they can't afford their deductible, let's say
mhm.
some patients have big deductibles, $6,000, $8,000, $10,000. We can work with the patient to make sure that that's not a barrier to them getting the best treatment that they need.
That's awesome.
And we're in net, and I should mention too that we're in network with all of the major payers, Blue Cross, United, Aetna, Cigna, et cetera.
Perfect. Now, will we, have any side effects from the protons?
Yeah, so proton therapy, it depends on the cancer. So we'll talk specifically about breast cancer. There's acute side effects, and then there's long-term side effects. So acute side effects, most often, I know you know this, Sarah, is a lot of that's going to be the radiation burning that can occur as the radiation's going into the body. Our skin cells are some of the most sensitive cells in our entire body to radiation. That's why you can go stand out in the sun for 15 minutes and get a sunburn. That's radiation coming from the sun. So as that radiation is getting delivered, and this is the case with X-ray radiation or proton radiation, it's just a fact of the matter that there's going to be skin cells that are exposed to radiation, and you can get burning from that. And we do the best we can to try to minimize the dose on the skin. And certainly there's topical treatments that we'll go through to try to manage that to help the women get through treatment.
Mhm,
Then you shift to the long-term side effects. So probably the most important long-term side effect for breast cancer patients to think about is heart toxicity. And this is especially important if you're treating the chest wall, so you're treating a pretty big area. So this would be like a post-mastectomy. Maybe there's lymph node involvement. And so again, you're treating a pretty big area. You're close to the chest, uh, but then also if it's left-sided, but then also some of the chemotherapy drugs are cardiotoxic. So then when you add all of that together, even a very little bit of radiation exposure to the heart can cause significant complications down the road, because you're going to get scarring, and then that can lead to worst case scenario, literally a heart attack,
mhm.
or heart failure. And so our goal is to, as much as possible, completely eliminate any dose to the heart. or if there is any dose, it's very, very minuscule. And again, with protons, you're always going to be able to do better at that than you are with X-rays. And we also, another technique that people sometimes talk about is deep inspiration breath hold. So you're going to hold your breath during treatment and expand your chest wall away from some of those critical structures like the heart and the lungs, and that gives a little bit more space. So if there's X-ray radiation going in to a treatment area, maybe there's a little bit of less exposure to the heart, and that's all good. And that's a really beneficial technique. But again, you can't stop X-rays. So even doing deep inspiration breath hold, you're oftentimes not going to be able to reduce the radiation dose to the heart as well as you can with protons. And we also can do deep inspiration breath hold with protons as well if we need to.
Okay.
And I would say, I would say,
Okay. Wow.
don't be afraid if you're a patient to ask your radiation oncologist, what is my dose? What's the dose to my heart? Like that is a question that you can write down on a piece of paper, walk into consult and say, you've developed the treatment plan. I would like to know how much radiation with this treatment plan is going to hit my heart. Patients should know that. And if it's any number above 0, then it's fair to say why. And are there things that we can do to get that radiation dose down more?
Awesome. Well, thank you so much about all the education that you've given us today about protons. I love listening to you talk about it. You help, I think the patients just raise some really good questions, helping them understand what they don't know. We talk a lot about that. So I really appreciate your time. But there is one other thing I want to talk about before we go. So tell me about your project. This is your podcast.
So the Cancer Project,
so tell us about that.
There's a podcast component to it, and the purpose of the podcast is to be educational. And we're talking to all different types of people: doctors, patients, researchers, politicians. Our last interview, we talked to Melissa Provenzano, who was the House sponsor for House Bill 1389, which expands guaranteed access to diagnostic breast imaging. With no out-of-pocket cost for patients. And so that was a really neat interview that'll come out in a few weeks. But there's a bigger purpose behind the Cancer Project, and that is really to address cancer outcomes in Oklahoma. Depending on the cancer type, we're anywhere from 45th to 50th. And if people don't remember their geography, there's only 50 states. So if you're 50th, that means you're last in cancer mortality here in Oklahoma. And so there's a variety of reasons for that. There's access to health insurance. There's access to good screening. There's awareness of when and why to screen. There's access to good treatment options, state-of-the-art treatment options, access to clinical research. There's a legislative component. What is the state government doing to help support cancer patients and address this issue that we have in the state, which, again, we're towards the bottom when it comes to cancer outcomes or cancer mortality. And so that's what we are doing as Oklahoma Proton Center, existing within this oncology community in the state. We feel an obligation to really do more to address that. And so part of that is, again, it's just education and awareness, which is where the podcast comes in. But then there'll be some other initiatives that we'll talk about later on in terms of just creating access for patients to good screening, good diagnostic imaging, and good treatment.
That's awesome. Well, okay, so
so the Cancer Project
is it just on any podcast platform?
It's on, we're on all the podcast platforms, Spotify, Apple, we're on YouTube. It's, there's a video component to it as well. There's a Cancer Project Instagram page, and then we post a lot of stuff. We cross-post on the Oklahoma Proton Center channel. And so I'll get you a link that you can send out to your support group, Sarah. But yeah, it's out there, and you were on there. You were an amazing guest. Can't wait to get that interview published here in a few weeks as well. So
awesome. Okay, so you guys go follow the Cancer Project, and then if you want to look into protons, go to OK Proton Center.
Or the phone number is 405-773-6700.
Okay, perfect. Well, David, thank you for being with us today. I always love talking to you. You're just a plethora of knowledge, and I hope, ladies, that you guys have enjoyed
Thanks, Sarah.
listening to him today. So we will see you next time.